In this video, we will explore the exact pressures required by the R410A refrigerant in air conditioning systems. We will also quickly analyze its thermodynamic behavior. R410A is a refrigerant widely used in air conditioning systems and water chillers. Although R410A is a high-efficiency gas, its main drawback is its high global warming potential, known as GWP, which is why it is currently being subjected to environmental restrictions. Next, we will observe the behavior of R410A in the cooling cycle. 1. Let's begin by selecting the R410A gas in the simulator and setting an evaporation or cooling temperature of 4 degrees Celsius, which is typical for air conditioning systems. 2. For a more accurate calculation, we will set the superheat adjustment to 5 degrees Celsius at the evaporator outlet. 3. Remember, superheat is the temperature increase of the refrigerant gas inside the evaporator coil, located in the indoor unit. 4. The superheat value varies according to the thermal load of the air conditioning system. For example, in a room or space with many people, the superheat may exceed 5 degrees Celsius. In contrast, with a lower thermal load or fewer people in the room, the superheat will be less than 5 degrees Celsius, potentially reaching 0 degrees Celsius when the cooling demand is very low. 5. Now let's focus on the condensation temperature within the air conditioning system. To calculate it, we will add 10 degrees Celsius to the ambient temperature outside the unit. For example, if the outdoor temperature is 30 degrees Celsius, the condensation temperature will be 40 degrees Celsius. By the way, the link to access this simulator is provided in the video description. 6. Now, let's select a subcooling value of 5 degrees Celsius. Subcooling is the reduction in refrigerant temperature when it is in liquid phase at the condenser outlet, which improves system efficiency. 7. For example, if the outer surface of the condenser is clean and there is a proper airflow, slightly higher subcooling values can be achieved. However, it is important to note that in hot climates or under more challenging heat exchange conditions at the condenser, such as low fan speed or dirt on the condenser coil, the subcooling may drop below 2 degrees Celsius, and in some cases, even reach 0 degrees Celsius. 8. The pressure shown on the system's gauge depends on the altitude above sea level. In this section of the simulator, we can select the altitude where the unit is located. This allows for a more accurate gauge pressure reading, which is crucial for high-precision refrigeration systems. 9. In this way, the gauge pressure will vary from one location to another. For example, at 1,000 meters above sea level, the low and high pressures adjust to the values shown on screen. 10. At 2,000 meters above sea level, the low and high pressures change according to the values shown in the diagram. 11. In this section of the simulator, we can view the discharge temperature. This is the temperature of the refrigerant immediately at the outlet of the compressor. Remember, the link to access this simulator is provided in the video description.